Hi, pre-calculus students. Today we're going to talk about section 3.6. So make sure you have your notes and something to write with. Make sure that as we're going through that you are pausing. Sorry, there's my arm. That you're pausing and trying problems on your own. Okay, so 3.6, there are a bunch of definitions here at the top, just some vocabulary. So when we talk about different functions and describe them, like we were describing with M behavior and increasing and decreasing and things like that, we talk about critical points and extrema. So critical points are those points on the graph at which a line drawn tangent to the curve is horizontal or vertical. So here are some examples of that right here. Tangent, remember, is a line that brushes the curve and only hits at one point. So here or here or here. So when we have some sort of maximum at a point or minimum at a point, or this we call where it kind of just changes curvature, a point of inflection. So when we have a maximum, right, the graph is increasing to the left and right, to the left of the value and decreasing to the right. A minimum, it's decreasing to the left of the value and increasing to the right. Point of inflection is where the curvature changes. So it's really increasing all along here, but the curvature changes. So within those, we have absolute maximum, absolute minimum. So the absolute maximum is the very highest value a function can assume over its domain, the very highest. And the absolute minimum is the least value a function can assume on its domain. Okay, those are called extremum or extrema. Okay, now a relative maximum and a relative minimum is the greatest interval or the least value, or greatest value or least value on a particular interval. So basically it's you have a turning point of some type or a point of inflection, but it's not the very highest or the very lowest. So if you look at these examples here, this point here is the very lowest. It's the absolute minimum. But this point here is the lowest point kind of relative to everything around it, right? It's the lowest point on that interval. So we would call this a relative minimum. And if I asked you, okay, well, what about absolute maximums for this graph? Well, it goes up forever and ever. There is no absolute greatest value on the whole domain. But this little point here where I have this turning point, right, where it's increasing on the left and decreasing on the right, we would call a relative maximum. Okay, in this graph here, that it has an absolute highest value, so an absolute maximum, but it goes down forever. It doesn't have an absolute min, and it doesn't have any other turning points, so it doesn't have any relatives. This one doesn't have any absolute max or absolute min because it goes up forever and down forever, but it does have these two turning points, so we have a relative maximum and a relative minimum. And that's what we're going to practice with today, is analyzing these graphs. So if you take a look at example 1, it says locate the extrema and then classify the extrema. So when it's asking you to locate and classify, it's like, okay, do you have a relative? Let's start actually with absolute. And I'm just going to abbreviate this a little bit. So do you have an absolute max? Do you have any relative maximums? Do you have an absolute minimum? Do you have a relative minimum? And it might be that you have all of them. In some cases, you maybe have 2 of one thing and none of the other thing. It's totally going to depend on the graph itself. So take a look at this graph and then see what you come up with. Because this goes up and down, up forever in both directions, we do not have an absolute maximum. But we do have right here this turning point where I'm changing from increasing to decreasing, and we would say that is our relative maximum. These you just give normally as an ordered pair. So I'm just going to list the point 0, 2. Absolute minimum. Do you have a where's the very lowest y value? The very lowest y value is at 0, and it's here and here. So here's an example where I have 2 absolute minimums at 2, 0, and negative 2, 0. And in this case, I don't have a turning point, a change from decreasing to increasing other than these absolutes. So I would say no here. Okay, so then here, take a look at this graph and same thing. Do you have an absolute max? What about a relative max? You have an absolute min. What about a relative min? Okay, this is again up, up on both ends, no absolute maximum. Okay, as I go, I've got 3 turning points. So I've got a turning point here, and here, and here. This is a maximum because it's increasing on the left and decreasing on the right. It's not an absolute maximum, so I would call it a relative maximum. Okay, between these two, which are minimums, absolute, which is the very lowest y value here at 4, -4, and then this isn't the absolute minimum, but it is decreasing on the left and increasing on the right. So -3, -1 is a relative. All right, now the last one, it says use a graphing calculator to graph this function and to determine and classify the extrema. So first we're going to graph this, and then we'll go through and say, okay, do I have an absolute max? Do I have a relative max? Do I have an absolute min? Do I have a relative min? So first thing you're going to do is graph it. You can graph it in Desmos, you can graph it on an Inspire, you can make a table if you really wanted to. I think that I am going to go for Desmos. Okay. I like Desmos because when I want to get those values, I don't have to go through like the analyze graph thing. I can just click and it gives them to me. So that is what I like about Desmos. All right. So I know I can't have this screen up and my .cam screen at the same time. So I'm going to do a sketch and I'm going to kind of write things down while we're talking about things. So when I go to get this, this graph, I'm going to get my max and min, but I'm also want to know where these intercepts are because it'll just make it more accurate. So I have one at -3 and I'm just jotting that down. Got one at 0.382 and what was that? Looks like 2.6. Okay, 2.618. I need the minimum. Well, it's not really a minimum, right? It's a relative minimum, but I want to know what that is. So 1.63 and then -5.7. Okay, and I want the guy up there. I'm going to drag this down so I can get this. Where are you? It says -1.63 and 11.7. Okay, so I jotted those down. So I'll bring this up so you can see what I had. All right, so this is what I got off of Desmos. You see how much faster that was than if I had gone through and done all that analyze graph stuff? What a pain. And these you just would have picked, when you did the analyze graph, instead of min or max, you would have picked 0. And that would have given you those intercepts. So when I go to get my graph now using this, I know I have to get up to 11.7 here, down to -5.7. This is only going from -3 to 3. So I think if I were graphing this, I would do a scale of 1 on my x's and a scale of 2 on my y's. So -1.63 would be about here. Oh wait, that's not what that was. Sorry. -3. Sorry. -3. This is at 0.382. This is at 2.6 something. And then it was at -1.363 and then 11. So 2, 4, 6, 8, 10, 11.7. So around there. And then 1.63, and that was 2, 4, about here. Okay, so using the graphing calculator helps you to get a more accurate graph. All right, then as for absolute maximum, we don't have one because it goes up forever. Relative maximum, or absolute minimum rather, we don't have because it goes up forever. But here I have an absolute maximum, so that was the -1.63, 11.7. And here I have a relative minimum, and that was the 1.63, -5.7. Okay, so this whole chapter is really about looking at graphs and analyzing them and what conclusions can you draw from all the information that you're given. Okay, so that wraps up section 6.